You're not recording again.
Okay. If you're just joining us, this will probably be a second recording, so what you need to do is watch this first, and then realize that the last one quit, so start the second recording now.
What?
Alright, so we have f of x equals 3 minus
So watch
1.
them say they have what figure.
Yeah, watch this one first, and then realize that the first one you're gonna watch, which will be technically the second one you watch, is gonna quit at some point, and at that point, start this one. There you go. Alright, so here is our thingy doodle. And you were to find the area under that curve. This all is, by the way, above the x-axis, so you don't need to worry about crossover with positives and negatives on the interval from -1 to 2. Okay, so remembering our Riemann sums, right 3. Okie dokie. We need to know first the width of each of our rectangles, and then second, which function values we're going to use. I kind of like to do this. You've got, imagine an interval going from -1 to 2, broken up into 3 pieces, like that. So rectangle number 1 would go from 0 to 1, then, I'm sorry, -1 to 0, 0 to 1, then 1 to 2. 3 rectangles. Each of those widths, the universal width, will be 1. For here, you might get lucky. I think y'all sometimes incorrectly assume that your width is 1. This one would not have hurt you. On part B, however, it is going to hurt you badly. So, right side, first rectangle goes from -1 to 0. The right side of that rectangle is at 0, so I'm going to plug in f of 0. Second rectangle goes from 0 to 1. I will use the right side, which is 1. Third rectangle goes from 1 to 2. The right side is 2. I'll take each of these values and plug them in. 0 is 3. 1 is 5/2, and 2 is 1, for a grand total, I believe, of 13/2 or 6.5, if I remember that correctly. Common mistakes I saw were to use the wrong values or to use an extra one. You use all 4 numbers. I saw some people use -1, 0, 1, and 2. You only get 3 to pick from, and it has to be the right 3. Now for L6, this is probably the irritating one, but it does set up, it basically does all the work for part C as well. If you do this one, you got all your answers for part C. L6, now if I'm breaking it into 6 pieces, that means my universal width is no longer going to be 1, but 1/2. And a common mistake I saw in both classes was to use 1 again for your width, which made your area twice as big as what it needed to be. Alright, so first rectangle will go from -1 to -1/2. The left side is -1. Then from -1/2 to 0, the left side is -1/2. Then, oopsie, then 0, then 1/2, then 1, 1, 2, 3, 4, 5, then 3/2, 6. Notice we're not using the 2 on the end because we use the left side of every rectangle. The last one would have stopped right there. Well, the good news is this. You already have a couple of these numbers done up here in part A, and there is a good deal of symmetry. For instance, because of the square, this one and this one are going to be the same, and this one and this one are going to be the same. So a lot of our work is already done for us, and we got this one from the original. So I'm going to have 1/2. F of -1 is going to be the same thing as f of 1 from the previous, so we're going to get 5/2. Stick in 1/2, you get a 1/4, times 1/2 is an 1/8. 3 minus an 1/8 is 23/8. 0 is 3. 1/2 is the same as -1/2, so another 23/8. 1 is the same as -1, so another 5/2, which leaves 3/2. That's going to be 9/4. 9/4 times 1/2 is 9/8. 24/8 minus 9/8 is 15/8. And you work your magic and you do your arithmetic, and I will cheat, and the right answer is 125/16, or 7.8125. You are using your calculating device. Midpoint 3. Now we're back to 3 rectangles, each of which will be 1 wide, okay? And these are going to be the midpoints. So first rectangle would go from -1 to 0. His midpoint is -0.5. Okay. What else? Second one goes from 0 to 1. His midpoint is 1/2.
1.5.
And then 1.5 for f of 3 halves. And those numbers are right here. So we get 23/8, and I'm pulling this straight off the last problem. Another 23/8, and a 15/8, for a grand total of 61/8, which is 7.625.
Pardon the interruption. The following students need to meet Ms. Eagles at the Tech Theater. Deja Barr, Jonica Brown, Zakia Floyd, Kiara Hemingway, Jamari Ward, Alexis Spain, Jade Moore, Denicia Long, Teresa Wilson, Maya Goins, Trevion Johnson, Joshua Livingston, Tanisha Griffin, Christopher Allen, Kiara Poole, Charlie Franklin, Uniqua Oliver, Nancy Edge, Nisea Williams, Cabray Holmes, Zaire Page, Leah Floyd, Dylan McNeil, Sterling Benning, Kia Garrett, and Savannah Kelly. Please meet Ms. Eagles at the Tech Theater at 12 o'clock. Thank you.
As a note, I did not ask it on this quiz, but they do like to use this one on the AP a lot. If they ever ask you to use the trapezoid approximation, that is just the average of the left and the right. And I can't really give you a good example because we did left 6 and right 3, so they won't go together. Yeah.
We times that by, it's really 1 times all that stuff. And number 2, it's 1/4 times all that stuff. Why is that?
Okay, let's look at number 2 then. Everybody cool with these examples and then that little note there. Number 2. This is number 1. Number 2. Number 2 says, if M4 is used to approximate this, from 0 to 1 of the square root of 1 plus x squared dx. Now we know, we know that this is an exact area under that graph on the interval from 0 to 1. So if we were to type that in our calculator, it would give us a decimal, which is wrong for this question, by the way. It would give us a decimal, and that would be the exact area up underneath that function. They want us to approximate that using M4, midpoint 4. So I'm thinking this. The interval we are choosing is from 0 to 1. We're cutting that into 4 rectangles. So how wide is each rectangle going to be? 1/4. Good. So every single rectangle is going to be 1/4 wide. So my universal width is 1/4. Like this one was 1/2, and these were 1s over here. Okay? But then they want me to use midpoint to make it even worse. All right, so here's rectangle number 1. The midpoint of 0 and 1/4 is 1/8. So I will do f of 1/8. The midpoint of 1/4 and 1/2 is 3/8. F of 3/8, f of 5/8, and f of 7/8. Okay? So then we'll type all this mess. Well, you have a calculator, and again, it's so tempting to just punch that in and get a decimal answer, but it's wrong for what they want. This is going to be the square root of, I think, 65 over 64. By the way, root of 64 is 8, and all of these fractions are going to be something over 8. If you're using your calculator anyway, don't waste the time trying to make it look fancy and make your fraction, whatever. Use the easiest thing to type in. This one, I think, and I'm going to cheat again, is 73 over 64. And all I'm doing is plugging these numbers in here and just writing it as a fraction. This one is 89 over 64, and this one is 113 over 64. So type all that mess into your calculator. I did see some people that got this far and then put their answers like 4 and some change. 4.5 or 6 or something like that, whatever. That's because they forgot this 1/4 out in front. If you do all this mess, it is 1.1459 ... 3 decimal places, 146. Okay? There's that one. Okay. Back to the beginning. This is why we recorded today, because there's no way we were going to cram all these problems onto the boards. They're kind of big.
Big messy problem.
Yeah. By the way, at this point, when you're doing the quiz, you're probably getting a little freaked out because you've done a heck of a lot of work for these 2 first problems, but it gets easier from here on out. The next one, you have the integral from -1 to 1 of x squared minus x minus 1 dx. Again, calculator will give you the answer if you really want it, and since you didn't get bonus points for trying it without a calculator, you could have done that. This one isn't that bad, however, if you want to practice your antiderivatives, which are honestly more common without a calculator. 1/2 x squared minus x from -1 to 1. I think the most amusing part to me, in a sick kind of way, is that your calculus is fantastic. Both classes, you're better at taking derivatives and antiderivatives. It's your algebra and your arithmetic that's still killing you. I don't know what to do about that. And right now I'm still trying to keep a real happy demeanor because I'm pissed as all get out at all the classes for their quest work. So 1/3 minus 1/2 minus 1 minus 1/3. No, I'm sorry, -1/3. Still minus 1/2, positive 1. Here's the deal, this -1/2 and this positive 1/2 will cancel each other out. This is going to be -2/3, I think. This is going to, okay, that is, hang on. I wouldn't have done that. This 1/3 and that 1/3 make 2/3. This -1 and that make -2, which is -4/3. Calculator, you already got -1.333333. Let's see, number 4. Without a calculator, you have the antiderivative from 0 to 1 of e to the -x dx. This is a teeny tiny u sub. This is the kind of u sub that you shouldn't even bother writing down. You're going to let u be -x, you're just going to get a negative in the problem. So this antiderivative is going to be -e to the -x. Go ahead and practice your u sub with u being -x, but that's what you're going to get. Y'all should start to recognize constants, that if all I'm going to do is just divide or multiply by some ridiculous constant, that's a 3-second question. All right, plug in -1. E to the -1 is 1 over e, so I'm going to get -1 over e minus. If you stick in 0, you do not get 0. E to the 0 is 1, so minus -1, which would have been a fine way to leave it. 1 minus 1 over e is how they would have put it on a multiple choice, which is 0.6321. And I'm going to give you more than 3 decimal places just to make sure your calculator is working right. They only want to see 3. Multiple choice, they would only put 3. Free response, they would grade the first 3 and then stop looking. So after that, you can just write whatever you want to. It doesn't matter. All right, 5. Number 5, again, is another one of those thank you questions. You have d dt, antiderivative from 0 to t of square root of x cubed plus 1 dx. Tried to fool you a little bit by flip-flopping the t's and x's in this one, but that shouldn't have been a big deal at all. We're just going to take this variable and swap it in for that variable, so our answer would be t cubed plus 1, and thanks. Notice that we did start with a constant, so there is no second piece to this, and our first one was not a fancy function like t squared or anything like that, so we just swapped it in. Done. 6. 6 is one we have done in class, so if you got that one wrong, there weren't good notes. 1 plus v to the 4th dv. Okay, this is where I started to see some pretty hideous mistakes with your u sub. U sub does use a derivative, but it uses it in a very specific spot. Okay, if you're going to take the derivative of this, that has no place here. Might be a nice quotient rule, but it has no place in this problem at all. The tricky part about this one is identifying what should u be. Your gut is going to tell you 1 plus v to the 4th. Okay? Your gut's going to tell you that. Because we've done a few of these, and if you let it be this, you're thinking natural log, is what you're thinking. At the bottom's going to be u, and the top's going to be du, and then we're going to do a natural log here. Problem is, you end up with this. Now the 4 doesn't bother me, but the v cubed does. I don't have a v cubed to cancel out. So, thanks for playing, but not it. All I have is a v. And if I'm going to use a v to cancel out, then I should have started with the v squared. Okay? So I'm going to let u be v squared. And what I'm trying to create is this. If u is v squared, then this would turn into u squared, and now I'm thinking arctangent. Okay? Because that's the field for the arctangent. So du is 2v dv, no 2, no problem. Like so. Here we go. Make a little room. All right. For this then, I would have a 1/2 antiderivative of 1 over 1 plus u squared du. And there's nothing else to doctor. That is arctangent. So my answer is going to be 1/2 arctangent of u plus c. We need to start worrying about the plus c because this is not a definite integral. So 1/2 arctangent of v squared plus c. Saw some very, very interesting attempts on this one. Number 7, we have antiderivative of x squared times x cubed minus 1 to the 5th. And I will say, if you got a 6 power somewhere in your problem, you were trying something right. Okay, trying something right. Wasn't quite there, but you were trying something right. My u is going to be x cubed minus 1 because I see his derivative in some form right there. Du would be 3x squared dx. I can take care of the 3. Okay, so now this, right here, becomes u, and the x squared dx becomes du. 1/3 u to the 5th du. Antiderivative of u to the 5th,
1/6. Oh.
yeah, is 1/6 u to the 6th plus c. 1/3 and 1/6 make 1/18, and u was x cubed minus 1 to the 6th plus c. All right, pretty straightforward. What did you, or that Michael's mess of crap.
Same thing.
Mess of crap. 8.
Mess of right crap.
Yeah, whatever. It's ugly. Find the area Under the secant squared, with x dx. On the interval from 0 to pi thirds. This was your red herring. Some of y'all were trying to create all kinds of really good use out of this. This isn't u sub. The antiderivative of secant squared is tangent. So, antiderivative is tangent. By definition, we've done that one a lot. Evaluated from 0 to pi thirds. You gotta remember your unit circle. Okay, tangent pi thirds. Here's the deal. I don't know my tangents, I'm sorry. I do know my sines and cosines though. Sine of pi thirds is root of 3 over 2, and cosine of pi thirds is 1/2, so it's root of 3 over 2 over 1/2, which is root of 3. Tangent of 0, sine over cosine, sine of 0 is 0, so our final answer is square root of 3, or somewhere in the 1.7 something something something, 732. Okay. So there's your quiz. There are both quizzes.
Oh, yeah, I remember.
So I hope you've learned a few things about this. I have, before I open this up to other questions, I have 2 other integrals I want to give you, 2 to try. They're U-sub problems. And I guess because you 2 are here today, and hopefully Jerry and Edward are here today, this will give you a leg up on the test. Those that are not here today, poo on them. Okay, let's tackle one like this. It's a U-sub, I'll warn you.
Ooh.
Now, I'm gonna do the indefinite, so don't forget your plus C. That's not really what I'm testing, but don't forget your plus C.
Ooh,
Okay,
that's a different.
So,
quiz.
this is not on the quiz, this is just, it is U-sub, but it's,
There's a difference of 2 squares, I know that.
okay, that's a true statement. What would you do with that information? Michael said it's a difference of 2 squares.
Go ahead and take out the square root.
What do you mean?
After,
It cancel, the square would cancel, the square and the 9 would cancel the square root.
also you can take.
Because I'm adding and subtracting, I don't get to do that.
Once the U sub's over, you should be able to do something about it. Right now you can't use U sub. It didn't work out.
What would U be?
9 minus x squared.
Okay, if U is 9 minus x squared, tell me what the problem is with that.
Oh, you get an x left over, never mind.
When I take his derivative, I'm gonna have an x left over, and I don't have an x to get rid of that.
Now, if we do difference of 2 squares.
So if you were to rewrite 9 minus x squared as 3 plus x, 3 minus x, not U sub by the way, but if you rewrite it like that, how does that help you? The correct answer is, it doesn't. Okay, interesting observation, does not help us. Let's do this. If this is a U sub problem, I kind of need to know what my target is. What am I trying to get it to look like?
We can, no, we can't.
So you need
Wait.
to identify this as one of your derivatives, or something close to one of your derivatives. Is it a polynomial? Is it a trig function? Is it exponential or log? Is it inverse trig? You have 5 to pick from. Polynomial, trig, inverse trig, exponential, or log.
So, it kinda looks like polynomial.
Kinda.
Could also look like inverse trig.
If it's inverse trig, which one?
What is it? And arc,
You'll need to know these.
arcsecant.
Sine. Arcsine.
Oh, yeah.
That's what this one is arcsine. Okay? Log would be a red herring. I do see 1 over something, but it's got that root in there, so I'm thinking not log, okay? Clearly not exponential, there's nothing in this problem that screams exponential at all.
Could be power, but too much we can't really use up to get to power.
Arc sine. So here's what we're shooting for then. That's arc sine. So we have to turn that into that.
Wait,
What's the first problem here? The first obvious problem here.
There's a 9.
There's a 9 in there instead of a 1. So let's fix that first. It's actually a relatively simple fix.
Take the square root. No, yeah. I'm stupid.
Factor it out,
Yeah.
okay? Factoring a 9 out of a 9 is the easy part, but if I'm gonna do that, I also have to factor a 9 out of the second piece. I have to factor a 9 out of everything. So what's this gonna become if I factor a 9 out?
On x squared over 9.
X squared over 9.
Yeah. I don't know how that helps you.
It helps us tremendously. Okay, let's do a little bit of algebra here. Okay, by the way, we can now take the
Yeah,
square root of
yeah.
9 because it's multiplication.
Almost at
So
3.
this is gonna be 1 over 3 square root of 1 minus x squared over 9 dx. Okay, I'm also gonna do this,
I'm gonna take that.
because it doesn't really
matter.
matter, okay? It's a constant. Okay, problem number 2. By the way, we didn't have problem number 2 in the front until we created problem number 1. Once we tried to fix this, we actually messed that up.
Now we have to fix that.
Now we have to fix that.
Which with the u sub, we could.
but-
Because we could
but
replace
then-
u for x over 9.
Here's the thing, I need to turn that x squared over 9 into something squared.
And then
So-
Turn x squared into u.
What was the thing I squared to get that? What was the thing I had to square to get this?
To get that.
To get this, what did I square?
X over 9.
Try again.
What?
That is not that.
Oh, x over 3.
X over 3. Ladies and gentlemen, that's you. Okay? So what is du going to be? If it helps. So what is du?
X over 3. Oh, it's 1/3
1/3
dx.
dx.
Oh, look.
That's actually convenient because here's a 1/3, forgot my dx, and there's the dx. All right, so we're going to write this as antiderivative. By the way, okay, this becomes 1 over square root of 1 minus u squared. The 1/3 and the dx together just become du. That's arc sine. That's it. So our antiderivative is arc sine
Of
of
3
u,
of x.
which is arc sine of
X thirds.
x thirds plus c. This type of problem doesn't usually creep up unless you're dealing with the arc trig functions, because your log is pretty much set at the bottom is u. That's it. This is the only one that gives you a little bit of wiggle room with what u is going to be. You see, what's irritating is if I stick a dinky little x, from the very beginning, I stick a dinky little x up top, this is not arc sine anymore, this is a polynomial. We let u be 9 minus x squared, we have the x to take care of it. So one stupid little x changes it from a level 2 problem to a level 8 problem. Okay? Alright, file that away under important. Got one more for you, and then we'll talk about test on Monday. May I clear? Everybody good this take?
Yeah.
Okay, give this a whirl.
Ew. Ew.
All right. Thoughts?
No, it doesn't do that.
Let's try and identify what it is.
Not fast.
Polynomial.
Thinking, no, no.
I'm thinking no.
I'm thinking natural log,
You're thinking natural log.
because we could somehow get that bottom.
Good. Let's run with that thought. If it's natural log, then that means my u has to be the bottom. Has to be, if you're doing natural log, u is the bottom. Okay? X squared plus 6x plus 10. So du is 2x plus 6 dx.
Dang,
Problem. Why?
there's a X still there.
Yeah, if it was just 6, I could take care of that, but I have this x in the problem, and there is no x up here for me to use to get rid of it. So,
No.
guess what it's not?
That.
Not log. Okay?
Can we factor the bottom? Not funly.
Alright, give it a go. It's a quadratic, so that's AC method, and it's a relatively easy AC method because the leading coefficient is 1. So let's find factors of 10 that add up to 6.
Oh wait.
5 and 2 get me to 7. Can't we just say it's close enough? Round it off?
Can we?
No.
I wish we could.
Okay, let's go down our checklist again. Not polynomial, not log. Trig,
I don't see any stress.
not trig.
Not tree.
Exponential,
No,
so what does that leave?
arc tree.
Arc trig.
But it doesn't look anything like arc tree. But at least you're gonna make a way. It looks like arc tree.
Well, let's think for a minute. Let's just assume for a moment that by process of elimination, this is arc trig.
Most of what it looks
Okay.
like is tangent.
Alright, it looks like, I don't see a root in this problem, so the only one, if it's going to be anything, I'm thinking arc tangent. Okay?
Again. No, wait, no.
This is what I'm thinking for the arc tangent. Alright, so here's my punt. If it's gonna have a chance of working, it has to turn into an arc tangent.
Which means we need a factor somehow to get the 6x plus 10 to turn to a 1.
Not the 6x plus 10, I like the way you're thinking, but we
Just
need
the
to create
6x
a
is what
1.
You need to create a
We need to
1.
create a plus 1. That's easy.